We all know what first law of thermodynamics is, which is just conservation of energy. But second law is more hidden and less well known. Yet second law is just as fundamental as first law, which we can never violate. Here we will use an example of your car engine to explain what second law says. First of all, you need to provide heat, QH, to the engine. And then what the engine does is to convert this heat, QH, into mechanical movement so you can drive your car. And the mechanical movement is called W cycle. If we only apply first law to our design, which is conservation of energy, then the equation is very straightforward. Total energy going into the engine must be equal to the total energy leaving the engine. So QH must be equal to cycle. If that's the case, what will happen to our efficiency of the engine? Eta. Efficiency is always defined as purpose over cost. The purpose of the car engine is to generate mechanical movement, which is W cycle, and the cost is to provide the heat released from combustion. So as you can see, if we only apply first law to our design, what will happen is W cycle is equal to QH, therefore the ratio between them is 1, telling us the efficiency will be equal to 100%, and we all know this is never true. This is wrong because we did not apply second law to our design. What second law says, you have to lose heat, QC. Think of the exhaust in the engine coming out, and then this heat is just lost to the environment, never coming back. So the second law says, during this process, you have to lose some heat. QC is never equal to 0. That's what the second law tells us. If we apply second law into our design, that means conservation energy equation will become QH. Total energy going into the system must be equal to total energy leaving. What is leaving is W cycle and QC. And now let's recalculate efficiency. Efficiency is defined as purpose over cost. Again, the purpose of the engine of your car is to give you mechanical motion, which is W cycle. And then the cost is to provide heat from combustion, QH. And now from here, we can rewrite the numerator W cycle from the conservation of energy equation. W cycle can be rewritten from this equation into Q hot minus Q cold. Denominator is still QH. So this equation just becomes 1 minus QC over QH. Second law tells us QC will never be 0. So QC will always be a positive number because second law says we have to lose heat. And the QH is the heat released from combustion, which will also be positive. Therefore, the whole second term in my right-hand side must be a positive number. And for 1 to minus a positive number, your solution has to be less than 1. And now everything checks out because efficiency is never as high as 100%, and we just proved it. The reason for eta efficiency to never be as high as 100% is because QC is never 0, and that's dictated by second law. So second law is the real reason why the efficiency is never 100%.